and then we will challenge your concept if you have learned it or not. This is Shahab Ahmad, and the channel is Defying Mediocrity. So first of all, look at the definition of Dalton's law, the postulate of Dalton's law. What does it say? It is saying that the total pressure of a mixture of gases, like you have a mixture of gases, the total pressure of that mixture would be equal to the sum of the individual pressure of gases. But there are two constraints in that. Number one constraint is that these gases you are mixing together should not be reactable. They should not react with each other. So, non-reacting gases. Another constraint is that you must keep two things constant. That is the temperature of the reacting gases. The temperature at the initial stage must be equal to after the temperature after you mix them, and their volume should remain constant. So the container in which they were present individually must be equal to the container after you mix them together. Okay, now look at this. Look at over here. So suppose I had a gas 1 at pressure P1. So from the general gas equation as we derived it in length in the first video we did about gases, that P equals nRT. So if I were to find P pressure of the gas, this gas P1, it would be equal to, we consider our equation, P1 equals to N1 RT over V. Okay, so this is the first pressure, the pressure of this gas. Now this P2 is the pressure of this gas, P2 gas. Okay, now I am trying to mix them both together, and I am supposing both of these gases are non-reacting. So gas 1 combines with gas 2 to form a mixture of these gases. So the black gas combines with the red gas, and now we are seeing them in total. So the P total here in this case would be equal to P1 plus P2. Okay, pressure over here plus pressure over here will give me total pressure of this combination, this mixture of gases. So intuitively it is very easy, like we can imagine it. What we did not change volume, we didn't change temperature, and R is already constant. So according to the general gas equation, P is equal to nRT. Now here is the number of moles of gas increases, so would the total pressure. So this becomes P total. P total is equal to number of moles of gas 1 plus number of moles of gas 2 into the other terms, that is temperature, volume. Okay, here again, if I want to find now the pressure of gas 1 in this mixture, that would be equal to the mole fraction of gas 1 multiply with the total pressure. Again, if I want to find the pressure in this mixture, it will have the same pressure that it would have in this case. Okay, so if I want to find now the pressure with respect to the total pressure, so the pressure of gas 1 here, the red, suppose I'm trying to find, would be equal to the mole fraction. What is mole fraction? That is equal to number of moles of gas 1 divided by total number of moles. So this is the mole fraction for gas 1, and same goes for 2. Okay, so if I multiply this mole fraction with the total pressure, that is PT of this whole mixture. So if I multiply the mole fraction of this gas 1 with the total pressure of this mixture, I will get P1, that is the partial pressure. P1 is the partial pressure of gas 1, partial pressure. Okay, here by P1 and P2 I mean partial pressures. P1 in case of gas 1 and P2 in case of gas 2. And now I think I clarified this concept of Dalton's law, that if you want to find the total pressure of mixture of gases that are non-reacting. We will discuss the case of reacting gases with the help of MCQ. We will clarify that concept. But if you are mixing gases that are non-reacting, you will see their behavior, their, their pressure. We discuss pressure in detail, that it is the bouncing of these molecules to the wall of container, and that bounce that exerts a force on the wall, and that force is called pressure. So the pressure, if you want to find the pressure in a mixture of a gas, you can find it like the total pressure in a mixture of a mixture. The total pressure of a mixture would be equal to the the sum of the pressure of the gases, if those gases were in those kind of in exact that volume present individually. So these pressures are not affecting one another. Simple terms, these pressures are not affecting one another. So if you then you are trying to find individual pressure, multiply that with the mole fraction, how much amount of that substance is present in that mixture. Now we will come to the MCQs and challenge or concepts now. Okay, MCQs number 1 is saying two gases, one is nitrogen, the other is oxygen. Having, I have written having 2 times, so having 4:1 in volume. Okay, now we have two gases. One is nitrogen and other is oxygen. And nitrogen in this mixture is present 4 times, and oxygen 1. 4 to 1, they are present in 4 to 1 ratio. If nitrogen, if I have 4 volumes of nitrogen, I have 1 volume of oxygen. Okay, in volume are mixed in empty container. So 4 volume of oxygen, 4 volume of nitrogen is mixed with 1 volume of oxygen. The friction of total pressure exerted by N2 is, now they are asking us to find the friction of pressure. How much pressure if total pressure was, now suppose in this case we have total volume of 5, 4 volume of nitrogen and 1 volume of oxygen. So 4 plus 1, I have total volume equals 5. Okay, now in total 5 volumes, how much nitrogen is present? Nitrogen is present 4. In total 5, I have, in total 5 volumes, I have 4 volumes of nitrogen. So it will have 4 4 fractions. Like if we take a fraction of this, so in total 5 fractions, I will have 4 over 5. The pressure exerted by nitrogen would be 4 over 5, because in total, as we can see over here, the pressure exerted by gas 1 is equal to, here suppose I take it nitrogen. So nitrogen, if I'm trying to find the pressure for nitrogen, here P1 represents nitrogen, so Pn would be equal to mole fraction of nitrogen multiply with the total pressure. So here the friction of nitrogen, it is directly, now we can see that the pressure of nitrogen is directly proportional to the mole fraction of nitrogen. Okay, so the mole fraction of nitrogen is what? It is 4 in 5 multiply with Pt. Okay, so what we will see is that 4 over 5 of the pressure, the whole pressure, 4 over 5 of the pressure would be exerted by what? By nitrogen, because it is present 4 times. 4 volumes in 5 volumes is of nitrogen, so it will also exert 4 times 4 in 5. So in total pressure, suppose the total pressure was 5, so 4 over 5 of that pressure would be exerted by nitrogen. So our option C is the correct option. Another question is saying A mixture of gases containing 14 gram of nitrogen, 32 gram of O2, 24 gram of CH4, then the pressure, then the pressure, the partial pressure of oxygen is. So they are asking for the partial pressure of oxygen. And we have been given what is mixing together nitrogen, oxygen, and methane. So here what we will find is the number of moles of each of the substance, because weight is given, we can find the number of moles, and that is very easy. If we find the number of moles, then through this formula we can find the mole fraction. And finding the mole fractions, it will be easy. We will find the mole fraction of oxygen, and we will multiply that with the total pressure. And here the total pressure they have given it in the form of PT. We can see this. So we will multiply the mole fraction of oxygen in this mixture with the total pressure, and we will be able to find what? We will be able to find the partial pressure of oxygen. So for finding the mole fraction, we have to find, first of all, what? We have to convert these grams into moles. So 14 gram divided by what is the molar mass of nitrogen, that is 28. So 14 over 28 is equal to 0.5. So we have nitrogen 0.5 moles. Okay, then what is the number of moles in 32 gram of oxygen? So we have to divide mass in gram over molar mass. 32 by 32 is equal to 1. So this becomes 1 mole. Okay, here we have been provided with the grams of CH4. So the molar mass of CH4 is 16. So we have to divide 24 by 16. We will get 1.5. So now we have to combine. What is the formula for mole fraction? That is moles of the thing that I am trying to find. So I am trying to find the mole fraction of oxygen. So the mole fraction of oxygen, I have to put the number of moles of oxygen in the numerator, and that is equal to 1. And now here I have to add all the other number of moles. So other number of moles of nitrogen is 0.5 plus 1 for the oxygen plus 1.5 for methane. So in total I'll get 0.5 plus 1.5 becomes 2. 2 plus 1 becomes 3. So 1 over 3 is the mole fraction of oxygen. So I must multiply mole fraction with total pressure PT, that is total pressure of the whole mixture. So 1 by 3 multiply the total pressure of the gas would be the partial pressure of oxygen. That we now know. What is the formula? Suppose I'm trying to find the O2, the partial pressure of O2 would be equal to the multiplication of mole fraction of O2 multiply with the total pressure. So mole fraction of O2, we now find it 1 over 3 multiply with PT. So option B is the correct option. Now the other question, this is not conceptual. So the pressure of water vapors at a particular temperature is called, the pressure of water vapors is called aqueous tension. Dalton's law of partial pressure can be represented as, so here we are given with different options. We must find how can we represent Dalton law of partial pressure, as we wrote it over here. This is the way, this is also the way. So this means P is equal to, if this is total pressure, you can also find it if it is PT or PN, anything. So option D is the correct option. Now we will also discuss one more MCQs. For that I have to rub the board and write it down. The last question for today, we have to discuss it. The mixtures are given A, B, C, 3 mixtures of gases are given, and they are asking which one of these mixtures do not obey Dalton's law of partial pressure. So we must find out the mixture that reacts together. A mixture of gases that react, those gases react together. Okay, why? Because as we said in Dalton's law that the mixture of gases should not react together. So if they react together, this will not follow Dalton's law of partial pressure. So the first pair is pH3 and HCl, acid-base reaction. We will find pH4Cl as a product. NH3 and HCl, again acid-base reaction. We have seen this example, NH4Cl. And what about these gases? You might have known this. This is notorious for its used in World War One. Phosgene gas killed many people, and phosphine gas, people kill themselves with this. This is a pesticide. So both of them also react. They form what? PCl3 plus HCl plus carbon monoxide. So it means all of these means option A is this mixture, and this mixture. All of these, they react with one another. So these cannot follow Dalton's law of partial pressure. So means all of the above do not follow Dalton's law of partial pressure. So this was about it, and thank you for your time.